bit of knowledge before we get there. And so technically this is section 3.5 in your book is where we'll be starting at matrix operations. So operations are add, subtract, multiply. With matrices or with matrix algebra, there's no such thing as division. Okay, so we're going to just add, subtract, and multiply. So no division exists in the matrix world. So when you're looking at a matrix looks like something like this. You got rows and columns. Okay, so this one has 2 rows and 3 columns, right? And we need to know that because we need to know what the dimensions are. Row by column is how you tell how big a matrix is. When I ask you what are the dimensions of this matrix, you're going to tell me how many rows does it have, how many columns does it have. Okay, this one has 2 rows and 3 columns, so it's a 2 by 3 matrix is what we would call this. 2 by 3. 2 rows, 3 columns. Okay. That size matters when we do certain different operations. Knowing the size of the 2 matrices or 3 or 4 matrices that you're working with, what size they are matters whether we can even do the operation or not. Because sometimes you can't, based on the size of that. The parts inside are called elements. That's the parts inside. For the most part, ours will be numbers in there, but we're going to do some matrix equations mixed in here, and there'll be a few letters in there. We just got to solve for them, but they're called elements. So the elements inside. So B is an element of this matrix. E is an element on the second row, second column. That sort of idea. So when we talk about an element, I'm just talking about something that's inside the matrix for that. Okay. Now, the rules for the first operation that we're going to talk about are operations, are addition and subtraction. So there's a couple of rules that we need to know for addition and subtraction. Remember, order of operations wise, addition and subtraction are the same level. All right, so addition, subtraction. In order to add and subtract 2 matrices, that's the plural of matrix, is you've got to have 2 that are the same size, same dimensions, okay? Dimensions must match. If they don't match, you can't, it's an undefined operation. If the dimensions don't match, it's undefined. So to add something to a 2 by 3, you got to have another 2 by 3 to add them or subtract them. A 4 by 6 can only be added to another 4 by 6 or subtracted. Okay? They have to be the same size. If they're not the same size, it's an undefined operation. You just say undefined is what you would say. Okay, so let's look at an example, and I'm going to do this one by hand and then show you how to do it with a calculator just to get you the practice of doing that. I generally don't do addition and subtraction of matrices in the calculator, but I am going to show you how you could because it'll help us when we get to a much more complicated problem if we know how to put it in already. So the first matrix we're going to have is 3, -5, 6. That's the first row. The second row is 4, -2, 11. And I'm going to add that to this matrix. Okay. What dimension is this first matrix? 2 rows, 3 columns, so 2 by 3. So if I add something to it and I want it to be a defined operation, what size does it have to be? 2 by 3. It's got to be the same size. So let's use -12, 6, -4, 10, -8, +4. Okay. With matrix addition, you're going to add corresponding elements. So that means first row, first column, the 3. It's going to add to which number in the second one? The negative 12. And you're just going to match up and do the addition or subtraction if it's minus between. Okay? So if you're adding a 2 by 3 plus another 2 by 3, what size do you think your answer is going to be? It's going to be a 2 by 3. 3 plus negative 12, negative 9, negative 5 plus 6, 1, 6 plus negative 4, 2, 14, negative 10, and 15. And that is the solution to that matrix addition. Really the super easy thing. I don't do this in the calculator normally, unless it's like weird numbers, a bunch of fractions in there. Okay. Sometimes you do. Not all of our Algebra 1 classes have ever seen this, but yeah, there are some places that they do that in Algebra 1. I don't know that we've done that here in Algebra 1. So yeah, if you just transfer it here, it's very possible. Yeah, because it's not very complicated. It's pretty easy to do. All right. Now, let's put it in the graphing calculator so we can see how that works, how to put a matrix in our graphing calculator. So grab a calculator, and we're going to get to the matrix menu. In order to do that, you're going to hit the second button, the top left there, right underneath Y equals like second button down. Second, and then you're going to hit the X inverse button. It says matrix above it. And you should get to this kind of page. You may have stuff here, you may not, depending on who's got your calculator for you. Okay. Second, and then X to the negative 1 power. That's the matrix menu. Now, what we want to do is edit our matrices that are in there. So we want to edit matrix A. So we need to press the right arrow key until we get to the edit menu. And then press enter. And the first thing that you do when you're putting a matrix in is you put the dimensions in. So we got a 2 by 3. Mine happened to be a 2 by 3 from some time before when I was using this. Okay. 2, hit enter, then type a 3, hit enter. And so type the rows by columns. So row, enter, column, enter. And then it should draw the matrix for you. So you should be able to see it looking like the right size. Okay. And then you just put in the elements just like they are in that first one. So we're going to put matrix A is going to be the first one, that 3, negative 5, 6, 4, negative 2, 11. So I'm going to type those in. 3, and then I hit enter, and it'll move to the next spot. Negative 5. Yeah, I didn't get the negative in there. Negative 5. Hit enter. And then 6, and hit enter. And it moves to the next row. 4, negative 2, and 11. Okay, so we've entered in matrix A. Everybody got that in? I want to run off and leave anybody on this first one. All right, now we got to enter another matrix. Got to enter the second matrix there. So let's hit second and then the mode button to get back to the regular calculator screen. And then go back to the matrix menu. Second, X inverse. Second mode gets you back to the regular calculator screen, and then you're going to go back to the matrix menu. We're going to go over to edit again and do matrix B this time. So go over to edit, press the down arrow to get to matrix B or any of the other ones. It doesn't matter where you put that. You just got to remember where you put it. Okay. So I'm going to put it in matrix B. I'm going to hit enter. And matrix B is a 2 by 3. Are we lost, ladies? Correct. All right, go back to your matrix menu. Second, X inverse. Second, matrix. Now press over. Right. then go down, press it down, and then use a B. See how B is highlighted? So now you're going to edit matrix B. It didn't erase your matrix A, it's still stored. Okay, you just got your element. So get in, and now you're going to type in that second matrix that we did in a second. Okay. Let's put in the second matrix. Let's see, we got -12, 6, -4, 10, -8, and +4. All right, well, everybody got that matrix in there? All right, now let's add them together. So we're hitting second, quit, to go back to the regular screen. And now this is where we're going to do that operation. So we got to go pick up those two matrices to add together. So I'm going to go second matrix, and the names thing that comes up first, that's where you're using them. Okay, it's not, you don't edit on this. When you edit over to the edit menu here, you're just picking them up to use in your problem. So I'm going to hit A, so I'm going to hit enter. And then I'm going to use my operation symbol. I'm adding, so I'm going to hit plus, and then I'm going to go pick up matrix B and use him. Second matrix B. When I hit enter, it's going to give me my answer. Hey, the same one we got before. Now, do you understand why I don't do those in the calculator usually? It takes forever, right, to type them all in. You guys are quicker than I am because you can use your thumbs to type stuff in, and I get to click one pencil mark at a time. So, but you get faster at putting them in. So addition and subtraction is really not, doing it with the calculator is probably not something you're going to do very often. But I want you to know you can do it with the calculator, just in case it's got some weird numbers in there and you're not sure. You're like, oh, I'm going to do that. Let's look at a subtraction problem, and then instead of having to re-enter more matrices, let's just use the same thing. Trevor? Yeah, that's what we did. Yeah, you can do it that way. You could do it that way. Yeah, that's right. Trevor asked, could you just do the individual parts like regular typing in your calculator? Yes. Are we going to have testing that have like different? We'll talk about that in just a second. Okay. We will. It'll be part of a nice quiz here. All right, so let's look at a subtraction problem. If we subtracted those two, so same two matrices, 3, -5, 6, 4, -2, 11, just to keep us from having to type them in again. And let's subtract them. It should equal a 2 by 3 when I get done. I'm going to press the up arrow and grab that problem because it's calling A and B. All I got to do is go press the back arrow, and I can change that to a minus sign instead of a plus sign. So I don't have to press so many buttons to go back and get matrix A and matrix B. So that's another, I'm trying to teach you a few tricks on the calculator as we go to do that. And subtract them. So that's doing it with the calculator. 3 minus -12 would be 15. And then, and then -5 minus 6 would be -11. And it's an organization of numbers. They can represent a lot of different things. We'll work with them in a little bit where we take systems of equations and put them into a matrix and use some of the matrix problems to solve it. You made a little bit today? Yeah. This is easy stuff. This shouldn't be anything that's homework. Well, tomorrow's a work day. You'll get the assignment today. Yeah. I don't know. Depends on what you do for a living. Okay. Probably not. All right. So not everything you do in school is something you're going to do. You're not going to write essays in real life. Y'all know that, right? Okay, so not everything you do in school is something you're going to do in real life. So we're going to subtract 6 minus -4 would be 10. And then 4 minus 10 would be -6. -2 minus 8, -8 would be +6. 11 minus 4 is 7, right? And that's the same matrix that I got with the calculator. Okay. If you had a different dimension of matrices, so maybe you got something that's 3, 4, 5, 6, 7, 8 minus -8, -9, -10, -11. What size is the first one? What size is the second one? 2 by 2. They're not the same size. Can you add or subtract it? No. You say it's undefined. If you didn't remember that and you tried to do it with your calculator, it would tell you dimension mismatch. It'd give you an error saying you can't do this. Okay? So knowing that the dimensions, that would save you from even having to type them in because you know they don't match up. And doing it that way. Again, I don't do addition and subtraction by calculator at all. I do it all by I'm quicker at it by hand. Okay. Exactly the same size. Yeah. You can't do the addition or subtraction. Okay. That's the rule about that. All right. Let's look at the next operation. It's called scalar multiplication. Again, a very easy concept. What you want to think about with scalar multiplication is distributive property. It's what it's like. It's not. You can't don't call it distributive property. Just think, oh, that's how you do this. Is you think distributive property. Scalar multiplication means taking a single number, fraction, whatever kind of number they give you, and multiplying every element by that number. So an example of that would be taking like the number 3 and multiplying it times this matrix. All that means to do, scalar multiplication, is distribute this 3 to every piece inside with multiplication. 3 times 6, 3 times 8, 3 times 7. 3 times -5, 3 times 11, 3 times -2. Okay. And this is another thing that I don't do in the calculator, but it can be done in the calculator. Okay. Scalar multiplication doesn't change the dimensions of your answer. It's still going to be what size is this matrix? 3 by 2. 3 rows, 2 columns. All right. 6 times 3 is 18. 3 times -5 is -15. 24, 33, 21, and -6. Scalar multiplication. If you were going to do scalar multiplication with the calculator, and I want to show you one of these. Let's say we had a scalar multiplier that was a fraction. That's the part that, this is where I might use the calculator. Okay. Maybe I'm multiplying 2/3 times, and I'm going to use one of those matrices that we used earlier that we've already got typed in. Let's do 3, -5, 6, 4, -2, 11. All right. That's an E. You tell me which one it is. You're the one that put them in your calculator. I don't know which one you put it in. So that's the thing where you got to remember where you put it in. Or if you're not sure, just type it, go and grab that matrix and hit enter, and it'll show it to you. Or you can go to the edit and you can look at it. Okay. So we put this into the calculator. This was matrix A for me. It was the first one I put in. And so I could go to the calculator and say 2/3 times, and then I'm going to go grab that matrix. Second matrix. Mine was matrix A. And hit enter. And I get all this, I get decimals because mine's set up to do that automatically, do decimals automatically. Some of yours may, for some reason, be set to do fraction answers automatically. And that's fine if it is. Okay. It's a preference type deal. If it comes back as decimals, well, some of you that had me before, my rule is that if it didn't have a decimal in the original problem, then the answer shouldn't have decimals. It should be fraction form. So this was fraction form to begin with. It didn't have decimal point, things in there. So I need to change those back to fractions. So the way you're doing that with the calculator is you press the math button and then enter twice. That changes whatever answer you got into fraction form. And the elements of a matrix can be fractions. Okay? So anytime you work out a problem and you get a decimal as an answer, but I need to give fractions for Mr. Isbell because he's picky about that part, then math, enter is how you're going to get there. Okay, math, enter. So that's our matrix after the scalar multiplication. 2, -10 thirds, 4, 8 thirds, -4 thirds, and 22 thirds. Okay, so did you try 2 divided by 3 times? And now hit math. Alright, so that's our matrix. 2, 10 thirds, 4, 8 thirds, -4 over 3, and 22 over 3. Alright, so we got those. So there's our resulting matrix. Okay? Now, let's combine scalar multiplication with addition and subtraction. Okay? Just like in maybe 7th and 8th grade math, 5th and 6th grade math, you did addition, subtraction, and then you did multiplication, division. We don't have division to deal with. We just have multiplication to deal with. And then you started putting it together and following order of operations. Okay? Order of operations happens the same way with the matrix as it does with regular numbers. Parentheses first, exponents, multiplication, no division to worry about, and then addition and subtraction. So that stuff, scalar multiplication is multiplication. So it's going to happen before the addition and subtraction does in that. So example F, let's say we had 2, 4, -1, 1, 0, 2, 7, plus 8, 3, -9, 5, 3, 20. Okay, so it's just a arithmetic problem. It's just doing numbers here. You can do it with the calculator if you want to. You could put in this is matrix A and this is matrix B, and then in your calculator get it to do 2 times matrix A plus matrix B, and it would crank out the answer. I don't want to waste the time typing it in because I can do that in my head probably quicker. Okay, because all I'm doing on this one is doing what with this 2? Distributing it to everybody inside. So I'm just going to do that one piece at a time because I know, are these the right dimensions to be able to add together? Yeah, we got a 3 by 2 and a 3 by 2. So I know I'm going to get an answer that's a 3 by 2. So I'm going to say 2 times 4 is 8 plus 8 would be 16. So my top left is 16. 2 times 1 is 2 plus -9, -7. 2 times 2 is 4 plus 3, +7. All right. And then go to the next column. 2 times -1, -2 plus 3, 1, right? 2 times 5, or 2 times 0 plus 5, be 0 plus 5, which is 5. 2 times, I don't know why my rows, I didn't line them up right. There, that's better. OCD was kicking in. 2 times 7 is 14 plus 20, 34. And that's That's how I would do that. I wouldn't do that with the calculator unless I was nervous and really wasn't sure about my arithmetic skills. And that's fine if you want to do it with the calculator, but it's going to take you a little longer than others. Okay. Now, out of this idea, this is where we get to the matrix equation stuff. Okay. So it's not necessarily solving for a particular matrix. It's solving for an X that's inside an element of a matrix. So it's just not really incredibly difficult stuff. This is not a system of equations. So this is just a matrix equation. I'm going to call it level 1 because when you get there are other matrix equations that are a lot higher level than this. So we're matrix equation level 1. So we're just going to get an example. And this is where we don't use the calculator a whole lot for this particular part. We're going to have a matrix equation. So we're going to have 3x plus 5. And then in the first, or not plus 5, just a positive 5. And then here we have 7, negative 2y. So that's a 2 by 2 matrix. I'm going to add. So what size does the next one have to be? 2 by 2, 8, negative 2, 4, 3. And when I add those two, I should get what size back? 2 by 2. Well, they're going to give me some information that says this is what it should add up to be. And they're going to say find x and y. This is not a system of equations, so we're not necessarily finding an ordered pair solution. We're going to do that in a little bit. But here we're just solving these two equations. So what we've got to think about is, okay, what's the equation that has the x in it? Okay, so 3x is right here. It's in the first spot. So it should go with everybody that's where? In that same spot, right? So the equation I could set up for the x's would be 3x plus what? 8 should be equal to 11. So I'm picking up this piece, the plus sign, that piece, and the 11, because that's the part that gets the x. Then that's just a regular old equation to solve, right? Just 3x plus 8 equals 11. Just solve that for x. How do we solve that for x? Yeah, subtract 8 from both sides, divide by 3. 3x equals 3, so x is 1. Let's find y. What's the equation that goes with y? Good job. 2y plus 3 equals negative 9. Corresponding elements with the operation between them. Solve that equation for y. Y would be 6 in that case. All right. Let's do one more equation, then we'll move on to multiplying matrices. We haven't done that yet. We'll make a tough one. This is about as tough as they get in this particular type of stuff for this particular course. So 3 parentheses, big set of parentheses, because there's matrices inside. 5x, negative 2, 6, negative 4, close the parentheses, plus 3, 7, negative 5, negative y, okay, and then close the parentheses. Negative 21, 15, 3, negative 24. Okay. Now, we're going to again solve for x and y in this problem. The difference is what? Yeah, I got that parentheses with the 3 outside. So when I write my two equations, they should have what? Parentheses with the 3 outside. Okay? So it looks like it's fancy stuff, but it's not. It's real easy. Okay, so we're going to set that up, and we got 3 parentheses. Let's do the x first. What's the corresponding elements for the x? 5x plus 3 equals negative 21. Not that hard to pull out an equation out of that. Then solve it. Whichever way you want to solve it. I'm going to solve it this way. And we'll see if we get the same answer, because I'm going to doubt some of you can do it that way. X is equal to negative 2. Okay? Let's get the equation for y. What's the equation for y? Three parentheses, negative 4. Yeah, or plus negative y or minus y, whichever way you want to write that, equals negative 24. So the corresponding parts for y go from there. And then I'm going to solve it a similar way, 5 by 3. And I really only do that because the number it's equal to is divisible by 3. If it wasn't divisible by that number, I'd distribute and work it out the normal way, probably. Unless I was just bored. So negative y is equal to negative 4, so y is equal to 4. So x is negative 2 and y is 4. May not get to solve the system today. That's okay. Oh, this will go fast. All right. So we've gotten this. Everybody okay with that? It's not too bad. Okay. So really easy parts there. All right. So I'm going to stay on the same paper, but I'm just going to point you and say this is 3/6 multiplying matrices. They gave it its own section, so you know it's a little bit more difficult than the others because it's multiplying matrices. Multiplying matrices doesn't work the same way as addition and subtraction. The rules for if the operation is defined is different. And then the rules for what kind of answer you get are different. So when you're multiplying matrices, row by column, and I'm using a subscript there. So I'm multiplying two matrices together. Their dimensions, I've got row 1, column 1. So this is the first matrix, the left-hand side one. The right-hand side one, I'm going to call it row 2 by column 2. These capital letters must match. The columns from the left-hand matrix have to match the number of rows from the right-hand matrix. Okay, left and right. Another rule that's different with matrices than with regular numbers. Regular numbers, if you say 3 times 2, you get 6, right? But if you do it the other way around, 2 times 3, you still get 6. Doesn't work that way with matrices. Okay? It's not matrix multiplication is not commutative, so you can't swap the order. So you got to be careful about that when we go to put that in and work it out. Okay. Now these two numbers have to match, and then our answer when we multiply them together is going to be row 1 by column 2. So the outsides are the size of your answer. And there's going to be questions on the EOC and things like that, and there may be questions on our quiz that say, if you multiply a 3x4 matrix times a 4x5 matrix, how big is the answer? What are the dimensions of the answer? Not even giving you two matrices to put together. You've got to just know that rule, okay? We're going to see that as we look at some examples of this, okay? So let's start with a couple of matrices to multiply. Let's start with this one. 2, -5, 6, 1. What size is that? 2 by 2. I'm going to multiply that.
Pardon the interruption. I need the junior high girls basketball team to meet out at the end of the junior high hallway for just a minute. Thank you.
All right. So if I'm going to multiply that by another matrix, or multiply that matrix times this right-hand matrix, it's got to have how many rows? 2. Because this is a 2, not because of the first part. Maybe I should have picked a different size. But this has got to be 2. So I'm going to use a 2 by 3. So let's do 7, 6, 4, and then -5, 3, 1. Okay. Matrix multiplication, I use the calculator for. I can show you how to do it without the calculator, but kind of like Kelly said, when am I going to use this in life? Probably never. So you're probably not going to have to know how to do this without the calculator. Ever. Okay? So the way it works by hand is you take this row times this column. 2 times 7 is 14, plus -5 times -5 is 25, and that's the first answer in the first part of the new. You go row times column all the way across, and that gets you row 1. And then you do this row times this column all the way across, and that gets you row 2. It's pretty easy to do once you learn how to do it, but I don't see any need in spending a whole lot of time working on that. That's if the first thing you want to realize here is these match. So that means my answer will be 2 by 3. Okay? 2 by 3. And the only way that you can multiply those two is if this one's columns match that one's rows. Okay? So in the calculator, we need to put these two matrices in. Okay, I'm gonna put this one in as matrix. We're not gonna use that matrix A and B that we had earlier again, so I'm just gonna put this one in as A and that one as B. Okay. 2, -5, 6, 1. Second matrix. Go over to edit, hit enter, and then put your dimensions of your first one in. So this is matrix A, so it's 2 by 2. I gotta remember 2, -5, 6, 1. 2, -5, 6, 1. Matrix A in there. Back to the matrix B. Oops, go to edit. Second matrix. Matrix B is a 2 by 3. And I don't know what the numbers are. 7, 6, 4. -5, 3, 1. All right. Now I'm going to multiply those. So I hit second mode to go back to the regular calculator screen. And I'm going to multiply those two matrices together. Make sure you put them in the right order. Matrix A times matrix B is the way that I've typed them in. So I'm going to grab matrix A, second matrix A. I usually type the times symbol in there so that I'm going to make sure I'm multiplying here. And then second matrix B. And there I have my 2 by 3 matrix answer. 39, -3, +3. Yeah. Oh, bless you. Well, it's not as hard as the class gets. We get a lot harder than this. Just these, no, they don't get any harder than that. And then what was the bottom part of that? 37, 39, 25. 37, 39, 25. And there we have that. If these two numbers don't match, it's undefined. Just like if the two matrices are not the same size in addition to subtraction, it's undefined. If you try to do that with your calculator and they didn't match, it's going to give you an error. Okay, so you've got kind of a buffer system in between you and the answer with the calculator that it's going to tell you something's wrong, and you should know to go back and check. Did I type them in the right way? Did I ask it to multiply them in the right order? Because if I tried to do matrix B, the second one times the first one, it doesn't work. Because if I swap the order, the dimensions aren't the right way. Okay, so you got to be careful of that. All right. One example of multiplication. I do the multiplication usually with the calculator. When I was in college, we weren't allowed to use the calculator. I had to do it by hand. But I've never encountered a situation where I needed to do that by hand. And I'm a math teacher. So I don't figure you will either. So even if you're going to school for engineering, you're probably going to be using much larger matrices than this, and they're going to give you some technology help with that. We used my linear algebra class. We had to write programs for to work with matrices, and the matrices came from equations and things, and they were huge, like 30 by 50 stuff. I mean, that kind of size. It's too big to work with by hand, so we used a computer program to do it. So that's what most of the matrix stuff, and that's one of the reasons the matrix is useful, is the fact that it doesn't have the letters in there usually when you're doing operations with it. So a computer system handles it better than something that's got variables in it. So that's one of the pluses to a matrix. If anybody in here does live sound, there's a way of mixing stuff using matrices and submixing with matrices. It's interesting, but it's the same idea as this. It simplifies things for you. So I'm going to go to 3.7, and we're going to do this thing called determinants. Determinants only exist for square matrices. Only exists for square matrices. All right. What's a square matrix? Perfect. Absolutely. Something's square, it's got the same size both directions, right? So the same number of rows and columns. So square matrix would be n by n, whatever size, 3 by 3, 4 by 4, 18 by 18, that sort of thing. Okay. So a determinant is like a property of a matrix. Okay. And based on what the determinant is, of a square matrix, when we get into systems of equations, there's some rules about which systems have solutions and which don't. Remember the infinitely many or the no solution situation. And it's based on what the determinant is of the coefficient matrix, which we'll talk about in a little while. But determinant is just like a property. It's a number that kind of represents something about this matrix. Okay, it really doesn't have any bearing on how the matrix adds or subtracts, but it has. It's just a property of it. It's kind of like that wall is kind of white-ish, or the door is wood. That's a property of it. It's what it's made out of. Okay, the determinant of a matrix is just like a property of it. It's something about a matrix that we want to know. Okay, now for matrices, square matrices, a 2 by 2 And notice that I didn't put the square brackets on that. It's like straight up and down lines. Looks like the absolute value marks. That's what that looks like. That's symbols. That's the symbol for determinant. Okay, is absolute value marks around a matrix. That means determinant of that matrix. Okay, with a 2 by 2, I usually do those by hand, but anything bigger than that, I use the calculator for. The reason I use it, do it by hand for the 2 by 2s is because it's just 2 quick multiplications and a subtraction, and you have it. I'm quicker at that than I am typing it in the calculator. I'll show you how to type it in the calculator and get it to do it for you just to check it. But the way it's done is you multiply diagonals. A times D minus B times C. Or B times C. And that finds it. So example of that, this is new section, so example A. If I had the determinant of 5, 4, 3, 7. Okay. I'm going to multiply diagonals. 5 times 7 minus 4 times 3. That'd be 35 minus 12, which is 23. That has a determinant of 23. We'll show you how to do that on the calculator. 2 by 2s, again, I do them by hand because it's quicker. But I'm going to show you how to get that with the calculator, and then we'll do a bigger one. Okay. With the calculator, you're going to go enter that matrix. So I'm going to go to second matrix, go over to edit, and I'm going to pick a matrix to put that into. I'm going to put it into matrix A. A 2 by 2, 5, 4, 3, 7. Okay. Once you get that in there, go back to the regular calculator screen. So second mode to quit, and I'm clearing that so it'll get back to the top. And then I want to get the determinant of that matrix. And one way to get that is to press second matrix to go to that menu, and a determinant is doing some math with that. I'm going to press over to the right. And number 1 says DET. That means determinant. Okay, DET is determinant. So press enter. And then I need to tell it what to take the determinant of, so I go get that matrix. Matrix A. And hit enter. And it gives me back that determinant that I found a little bit ago with 23. Okay? 2 by 2s I do by hand. Anything bigger than that, I'm going to do with the calculator because it is quite the lengthy process to do it by hand with a larger one. Even just going one step further, a 3 by 3 has 1, 2, 3, 1. Well, technically 1 operation, 2 operations, 3 operations, 4, 5, 6, 7, 8, 9 different operations to get the answer for a determinant on a 3 by 3, as opposed to 1, 2, 3 operations on the 2 by 2. So it squared the number of operations you had to do. We went from 3 operations to 9 operations. You go to a 4 by 4, you're going to go to 27 operations as it goes to the third power. And then you're going to go to, for a 5 by 5, it's going to go to the 5th power, 3 to the 5th power operations. It's a lot. So let's do a bigger one that we have to do with calculator. So let's find the determinant. And sometimes they'll write it like this, DET, and they'll put a matrix in there. 2, -1, -3, 4, 1, 0, 3, -4, -2. Sometimes they'll write it that way. Sometimes they'll put it in the absolute value looking marks. Either way, it's find the determinant of that matrix. This is a 3 by 3. So I'm going to put that into the calculator as a 3 by 3 matrix. Let's do that. I'm not going to get the systems today. That's okay. I already know the answer, so 45, is that what y'all getting? Good. If you get 45, you got the right determinant. Not very difficult, right? All right, let's get an application of this. This is actually something you can use a determinant for, even though it's a property. And that's to find the area of a triangle. So sometimes you may have, how many people have taken the ACT in here already once, at least once? Okay. Did you see any of those geometry problems where they had like a triangle drawn on a coordinate plane and they asked you to find the area of it? If you hadn't seen one of those, you might see one of those in the future. And it's like, okay, how do I figure that out? Because I got to find the height of the triangle and then how long's the base. So you got to think, I've got to do 3 different distance formulas before I can even start this problem. And I have 60 minutes to do 60 questions. There's got to be a better way. Welcome to the better way, determinants. Okay. So area of a triangle can be found using determinants. What's the formula for area of a triangle? Yeah, 1/2 base times height. Okay. What we're going to do is we're going to take I'm going to sketch a coordinate plane here, and I'm just going to pick some points. 3, 15. That point is 2, 5. And then 10, 8. I'm just guessing it where there would be. And we get this triangle drawn here. Those are the vertices of that triangle. The corners of that triangle are there. Okay. With matrix algebra or matrix determinants, we can find what the base times the height is using a determinant. And the way you do that is you take 1/2 times the determinant of the ordered pairs. So we got 3 ordered pairs, but we got to remember a determinant can only be done for what size of the matrix. Got to be what kind? Squared. This is not squared, so we need another column here. That column, just fill it up with 1s. Because if the way the determinant works is a lot of multiplications happening. If you multiply stuff by 1, it's not going to change anything, right? So that's why the 1s are working there. If you put zeros there, 0 does change things when you multiply by it. 1 does not. So that's why we're filling it up with 1s. Now, what do we know about area? It's always what kind of number? The area of this piece of paper is always what kind of number? Well, it's square units. But is it a positive or negative number? Always positive. Area is never negative. Okay? Area is always positive. Okay? So when we find the determinant of that matrix, then it may be positive or negative. We just got to remember it's always positive. No matter what happens, change it to positive. Okay? For area. So for this particular problem, we're going to use these ordered pairs as our x's and y's. Okay? So you're going to it doesn't matter what order you put the ordered pairs in there. Okay, as long as you put them together. 3, 15, 2, 5, 10, 8, or if you wanted to start with 10, 8 and then go to the next. It doesn't matter what order you put them in there, but we're going to put them in there. Okay, so I'm going to give myself some more room here. We're about done for the day, guys. Tomorrow is a work day, so don't panic thinking you're going to have a ton of homework tonight. You're not. Determinant, and I'm just going to put 2, 5, 10, 8, 3, 15, and then put the 1s there. And I'm going to find the determinant of that matrix. Okay, so type that in and find the determinant of that matrix. How much? Negative 77 is the determinant, or is the answer to the whole problem? Is the determinant. So Trevor says that the determinant is 77. Remember, it's area, so we're going to change it to positive, no matter what it turns out to be. Y'all agree with the 77? Because I don't want to. Okay. Half of that. 35 plus 3.5, 38.5. And we'd say square units. So there's an option for that. All right, so problems that you need to look at over the next, or tomorrow when we're in class, okay? So got a lot going on here. Page 207, 3 through 18, 22 through 27. If you want to stay and write these down, you can. If you've got to go, they will be here tomorrow. I promise you that, okay? Thank you very much. If you borrowed a calculator, make sure you drop it here with me. Homework, if you don't get your homework turned into me today, bring it tomorrow from yesterday, page 164. Thank you. And then page 191, 4 through 27. Have a nice day. All right, you too. 199, 10 through 18, 2 through 31.